For question number 2, we are finding the area of each shaded sector of a circle, and we're leaving our answers in terms of pi. So for number 2, this is the image we're working with. We have a diameter of 20 meters, and we have a sector that has a central angle of 48 degrees. So to remind ourselves of the formula, we have our area of a sector being the arc degrees divided by the total times the area. So the area of our sector. Okay, now it's pretty important that you put area of a sector because we have lots of different A's. We have area of a circle, we have area of sector, we have area of segments. And so when you're labeling it, it's just easier to label it like this, especially when we get into the next type of problem. So the area of the sector, we have a degree of 48 degrees divided by a total of 360. And we need to multiply that by pi times the radius squared. Well, in this scenario, we have the diameter. So remember, the radius is half the diameter, so half of 20 would be 10. So r would be 10, and we would square it. Then we would simplify that expression. And 10 squared is 100, so timesing by 100 pi. And then you can go ahead and multiply these two together and simplify it into a fraction. And we would get 40 thirds pi. And then label it. We have a label of meters. And remember, area is squared, so it'd be meters squared. So the area of this sector is 40 thirds pi meters squared. I'm going to go ahead and switch to number 3, pause if need. Okay, and then this is the image we have for number 3. We have the shaded region. We have a radius of 8 feet, and we have a central angle of 72 degrees in reference to this part of the sector. Now the problem is we want the area of the shaded sector. So we're gonna have to do a little bit of math to figure that out. So in order to figure out this, excuse me, this degree, we'll have to take 72 away from 360, which gives me an answer of 288. So all this is 288. Okay. So my area of my sector is 288 divided by 360 times my radius, which is pi times 8 squared. And we simplify our area. 8 squared is 64 pi. And then we multiply and simplify, and we get 256 fifths pi, and the label is feet, so it would be feet squared. So that would be a problem, how you would do that if your shaded region is actually opposite of the angle measurement that you were given. The next type of problem we're going to do is area of a segment of a circle. So we had the regular circle area, we had a sector, and now we have a segment. Lots of vocab. So area of a segment of a circle. Well, what is a segment? So a segment is a part of a circle bounded by an arc and a segment connected by the arc endpoints. Okay, part of a circle bounded by an arc and a segment, and it is connected by the arc endpoints. So what does that look like? It actually ends up looking like such. This is an example of a segment of a circle. Okay, now how does that really come about? So this next visual cue will help us greatly when showing where that really comes from. Okay, so it says that it is a part of a circle bounded by an arc and a segment. So first I'm going to show you where we get our sector. Okay, so we have our sector. And remember, a sector is like a slice of pie. So it looks like this. Then we have a segment that is created by that. And so in order to go from a sector to a segment, we have to take away part of the sector. And what ends up being taken away is a triangle. So you're going to subtract the triangle within the sector . And so you start with your sector, subtract that triangle, and that's how you're left with your segment. So again, area of a sector minus the area of the triangle equals the area of the segment. So when we do our problems, we'll first find the area of the entire sector, then we'll find the area of the triangle, and we'll subtract to find the area of the segment. So it is a two-step process in order to solve.